This is Mr. Gillum, and today we're going to be incorporating art into math. And one of the main pieces that an artist named Ellsworth Kelly is famous for is called Colors for a Large Wall. This piece of art actually came from the leftover scraps from another piece of art that he was working on called Spectrum Colors Arranged by Chance. And so he was making this collage and he had leftovers, and so he wanted to make another piece of art. And so in Colors for a Large Wall, white is a dominant color because he didn't have enough colors left from his previous project for the new project that he was working on. And so what he would do is he would match the hues of the colors with oil paint and arrange the panels according to his paper study. This is a picture of Ellsworth Kelly next to his Colors for a Large Wall painting. Or I should say it's a collage, and he was actually in service in World War II, and what he went to do after he had served in World War II is he went to France to study art. And so in Europe, artists were using all colors of the spectrum with full intensity. So when he returned to the States in New York, he painted with this idea of using color at its full intensity and created Colors for a Large Wall. At that time, in New York, abstract expressionists were rebelling against bright colors and began mixing colors, which muddled their hues. And so in the 1960s, pop artists began using bright colors again. So this guy, Ellsworth, was one of the first pop artists in the States. And so that's kind of his claim to fame there. So he's a veteran. He studied art afterwards. He began doing new things that maybe weren't accepted in the art world when he came back after studying art in France. So when we look at Colors for a Large Wall, there's a few things that come to mind that maybe we notice. And we're going to go through these one at a time. In this case, his Colors for a Large Wall is 8 by 8. So being 8 by 8 means 8 squares by 8 squares. That also can, well, it's an area problem really. There are 64 squares total, and that's going to be important here in a little bit. 64 panels. It's a mathematical system. Okay, they're supposed to be placed at random with the white and the black colors supposed to represent conflict and controversy, but it's supposed to be all random in his work of art. It's supposed to be simple. It's supposed to be abstract. He uses bright colors, dark colors, whites. Radical ideas were inspiration, and it was liberating, and his sense of freedom was captured in these because this style of art wasn't really. He was like a progressive artist for that time. So when I look at this point, we're actually going to analyze it mathematically. And I have a picture of his work, and I have this chart that I've made. And the chart has several columns. One is for color, number, fraction, decimal, and percent. And so in class, we are going to actually make our own abstract art. And we're going to analyze our own art pieces. But in order to do that, I think we should analyze another one so we have a good example. So for the color, I know on your paper it's black and white, but I'm going to try to number the ones, the shapes that I think are the same color on the board, and so we don't use any of them twice on accident. So let's start with the color black. It's in the top left-hand corner, so we'll start there, black. Okay. When I look at the color black, I'm going to count up the number of squares that I see that are black squares. I think we have like a black and a gray, and it's really kind of hard for me to tell, so we're just going to go with the best that I can figure out for the black squares. And so I'm going to say that this one, 2, 3, those are all black. 4 over here, and then we have 5, 6, 7, 8, 9, 10. Is there 10 total black squares? 2, 3. 8, 9, 10. It's really hard for me to tell if that one's black or not. Okay, this one is not black, I don't think. I think this one is black. 8, 9, 10, and I think that I got all of the black squares. I'm going to go ahead and say that this last one in the corner that I thought was black in the beginning, I'm going to say that that one is black as well. So I have 11 black squares. Okay, let's go to the next color. Let's do white. Since it's the next one over, we're going to do the white squares next. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there are 28 white squares altogether. Let's go to the next color over, and that looks like, we can call that color like light purple. I'm not sure. Light purple, and there's not a ton of that color. I see light purple. I say this one is 1, and that one's number 2, so I think there's only 2 light purples. And I'm looking at oranges now, so there's 1 orange, 2 oranges is what I see. So orange, 2. And let's go with light blue here. I see 1, 2, 3 light blues. And so my markers are lagging a little bit. There we go. I see 3 of those. Now I'm looking at yellows. I see 1, 2 yellows. I see 1, 2, 3 gray. I'm looking for pink. I see 1, 2, 3 pink. I'm looking for, we'll go with dark blue. Dark blue. I see 1, 2 dark blues. I see 1, 2 tans. We're going to call it tan. I see 2 of those. I see 1, 2 red. And now I'm looking for purple. I see 1, 2, 3, 4 purple. And I think I have everything now, but just to be sure, I know that because it's an 8x8 piece of art, I should have 64 total squares. So let's count these up. I see 28, 29, 30, 32, 35, 37, 40, 43, 45, 47, 49, 53, and at the top, I hope there's a little bit more up here. And 11 makes 64. Perfect. We have everything. We have every square accounted for in a different color. Let's write those as fractions. And when we're going to write them as a fraction, I'm going to have those written as a fraction as a whole. So 11 of the 64 squares are black. 28 of the 64 squares are white. 2 of the 64 squares are purple, light purple. 2 of the 64 squares are orange. 3 of the 64 squares are blue. 2 of the 64 squares are yellow. 3 of the 64 are gray. 3 of the 64 are pink. 2 of the 64 are dark blue. 2 of the 64 are tan. 2 of the 64 are red. And 4 of the 64 are purple. Okay, and so that's just as simple as the fraction column needs to be. I don't need you to reduce those for today. We haven't really talked too much about that. We could find equivalent ratios to those. That's not necessary for now. We'll talk about that more when we get to the numbers, number system. But now, writing it as a decimal can be a little trickier. Right now we have them as fractions, and on your assignment you're actually going to have a little bit easier fractions to work with. But for ours, we're going to calculate the decimal by using that fraction bar as division. And so what I'm going to do is I'm actually going to get my calculator out. I'm going to calculate what each fraction would be as a decimal. And to do that, I'm going to treat the fraction bar as a divide sign. So to figure this decimal, I'm going to do 11 divided by 64. To find this next fraction in decimal form, I'm going to do 28 divided by 64. And again, that fraction bar just means division. 2 divided by 64. Okay, and then this one would be the same thing. And then 3 divided by 64. And then again, we have 2 divided by 64, and we have 3 divided by 64, 3 divided by 64. So we have some repeats here all the way down. And so what I'm going to do is I'm going to go ahead and pull my calculator out, and I'm going to do that calculation. So I did all my calculations off camera, and I've written them down in blue. But what I did is I literally typed in exactly what I wrote in green. So to find light blue, I did 3, and I clicked the divide sign, 64, and I figured out what that equaled, and it was 0.046875. And that's what I wrote down. So you may have to pause it there to get these lower values, because I'm going to scroll back up again here. So we now have represented the work in fraction form and in decimal form. And again, I just took the top divided by the bottom. And now we need to write as a percent. Now we know that percent means per 100. And so when we talk about moving from a decimal to a percent, really what we're doing is we are multiplying by 100. So if we're going from decimal to percent, we're multiplying by 100. And I like multiplying by 100 because I know that really what that means is that we are just moving the decimal place 2 spots. So in decimal form, black would be 0.171875. In percent form, if we're talking about percent, we would move that twice. It would be 17.1875%. Okay, I just moved that decimal 2 spots. If I know the decimal is 4375, as a percent, it would be 43.75%. Okay, per 100. So I'm multiplying by 100. The 100 is really important for percent, knowing that number. This one said 0.03125, and so I wouldn't write 0.03125%. I would just write 3.125%. I wouldn't need to write the 0 in front of the 3. Again, I would have the same thing. That's the same exact calculation. This time I have 0.046875, so it would be 4.6875%. Okay, and then we have some repeated ones here, 125%, 4.6875%, and the same thing happens for several of these because they are the same calculation. But I hope that you're kind of getting the idea of how to change fractions into decimals into percents. And there's several ways to do this, but this is the way that I'd like you to do it for tomorrow. Calculate all the fractions, decimals, and percents. I think that you're probably going to be in good shape without a calculator tomorrow because your grid is going to be actually a 10 by 10 grid. And when you divide by 100, it's much easier than dividing by 64. So hopefully that will help some of these calculations and they won't be too messy. But as you can see, I've analyzed this specific work of art. You're going to analyze your own works of art. And the last thing I want to point out is how to check your answer. It's going to be kind of tricky for me to do that with these crazy percentages and stuff from his actual art, but there's a few things that I did to make sure that my answer was correct. I knew that I had an 8 by 8 grid, so my total should be 64 total squares. If I count up my numbers here and I add all those numbers up, it should equal the total number of squares. This is the important part. When I add these fractions up, I should get 64 64ths, and that represents 1 whole or 100%. If that represents 100%, and I add all these decimals up, that should equal 1.0, and this should actually equal 100% if I've used all of the data. So for tomorrow, that's what we're going to do, and that's it for today.